Hello coders, I welcome you all. Today in this video, we are going to create a conversational chatbot using Google Gemini's free APIs, which looks something like this that you can see on the screen. But here, there are many things to learn. This is a highly practical session. So the main purpose of this video is to show you how we can interact with large language models using APIs. While many people are familiar with using chat interfaces like ChatGPT, right? LLMs can also be accessed programmatically via APIs. And in some cases, LLMs can be downloaded and run locally. But in this video, we are going to focus on using LLMs through APIs, application programming interface. The model will be running on Google's servers. So we don't need any extra space or heavy setup on our local machine. Using the provided APIs, we can easily build powerful applications that you can see here. So in this video, you will also learn about system prompts and user prompts that we are going to define using programming and how LLMs maintain conversational history in a chat session. So by the end of this video, we will also create a simple and interactive GUI using Gradio that you can see on the screen to demonstrate our chatbot in action. So let's get started. You can see that I am currently on the official Google DeepMind website. You can see deepmind.google. Let's click on technologies and we are interested in this Gemini. I'm using this website just to quickly show you the different variants of Google Gemini models that we are going to use to build our application. So here you can see Google describes Gemini as our most intelligent AI models built for the agentic era. You can see this means that models are designed not just to respond, but to assist and even take action like a real agent. So on this page, you will notice two main options: chat with Gemini and try in Google AI Studio. Let's first click on chat with Gemini. So clicking this takes you to a conversational interface of Gemini, kind of like ChatGPT, where you can directly chat with the model, ask questions, get help with coding, content writing, and anything else the model supports. Let's write what is machine learning. You can see this is a conversational interface, kind of like ChatGPT, where you can directly chat with the model. You can see, now let's move back and let's click here, try in Google AI Studio. So clicking this opens a new platform called Google AI Studio, which is a sort of playground that you can see where you can experiment with different prompts, test model responses, and tweak parameters. It is super useful for developers and creators who want to test ideas before integrating Gemini into their applications. So we will come back to this AI Studio page shortly because that's where we will generate our API key and start interacting with the model using code. Now let's move back to this particular website, deepmind.google, and we are inside technologies and Gemini. Now let's take a quick look at the different model variants available under the Gemini family. You can see Google Gemini model family, and here you can see Gemini 2.5 builds on the base of Gemini with native multimodality and a long context window. And here you can see different model family 2.5 Pro. So this is the most powerful and intelligent model to date. It supports native multimodality, means handling text, images, and audio, and offers a very long context window, perfect for complex conversations or big documentations. It performs exceptionally well in tasks like coding, reasoning, and advanced prompt handling. Next, Gemini 2.5 Flash. This one is optimized for speed. It's great when you need faster response times while still handling detailed tasks. Next, Gemini 2.0 Flash Lite. This model focuses on cost-efficient performance, ideal for lightweight or budget-sensitive applications. So as you can see, there is also a demo video available here if you want to explore it further. So now let's move on. And here you can see benchmarks. So before we dive into the results, let's first understand what are these benchmarks all about. This is very important. So benchmarks are standardized tests designed to evaluate the performance of AI models across a wide range of tasks. They give us a way to fairly compare models like Gemini, GPT 4.5, Claude, and others. And here are some of the key parameters being used in these comparisons. And first, you can see single attempt and multiple attempts. The single attempt shows the model's performance on the first try. It's a great measure of accuracy and reliability. And here you can see multiple attempts. Some tests allow retries. These check if the model improves with more chances and how consistent it is. So here you can see first benchmark test, reasoning and knowledge. Humanity's last exam, no tools. So what it tests? This is a tough benchmark that simulates high-level thinking exams. It tests how well a model can reason without using tools or web search, pure brain power. And here you can see the result. Gemini Pro scored the highest with 18.8%. It outperforming all other models. You can see OpenAI O3 Mini, OpenAI GPT 4.5, Claude 3.7 Sonnet, Grok 3 Beta, and DeepSeek R1. Now second, GPQA Diamond. We already discussed about single attempt and multiple attempts. So what it is? GPQA stands for Graduate Level Physics and Quantitative Analysis. This benchmark measures how well a model handles science facts and reasoning. And you can see the result. Gemini Pro achieved the top score with 84% in a single attempt. Others like OpenAI O3 Mini got 79.7%, OpenAI GPT 4.5 with 71.4%, and Claude 3.7 Sonnet with 78.2%, and Grok with 80.2%, DeepSeek R1 71.5%. That you can see. Next, advanced maths. You can see AIME, which stands for American Invitational Mathematics Exam. AIME is a real math competition. This checks how good a model is at solving challenging math problems with logical steps. And here, two competitions, 2025 and 2024. And you can see here, Gemini scored 86.7% in 2025 and 92% in 2024. And you can see score for others as well. And you can see Gemini Pro stood out with the highest scores that you can see. Now, next, code generation, live code bench V5. What it is? This checks how well the model can write code from scratch based on a given task. It measures by single attempt. And you can see Gemini performed strongly with 70.4%. And here you can see OpenAI and others. Now, next, code editing, either polyglot. What it is? Instead of writing new code, this benchmark checks how well a model can modify existing code, which is crucial for real-world debugging and improvements. You can see the result. Gemini achieved the highest score, 74% for whole files and 68.6% for different edits that you can see, and core for others. Next, agentic coding, SWE bench verified. What it is? SWE bench tests how well a model can act like a coding assistant, reading GitHub issues and making changes in a large code base. And Gemini scored 63.8%, and I think it is just behind Claude 3.7 Sonnet that you can see with 70.3%. Now next, factuality, simple QA. So what it is? Simple QA asks different factual questions to check how correct and confident the model's answers are. And you can see this OpenAI GPT 4.5 did best here with 62.5% and Gemini with 52.9%. But Gemini still performed well with GPT 4.5, right? Next, visual reasoning, MMMU. So what it is? This benchmark evaluates how well the model can understand and reason using images. And you can see Gemini top the chart with 81.7%. You can check score of others. Next, image understanding, Vibe Eval Rekha. What it is? Focuses on describing or analyzing visual inputs, and Gemini scored 69.9%. 0.4% and other model didn't support this test. Next, long context memory, MRCR. What it is? This benchmark test performance at 128K and 1 million tokens that you can see. Gemini dominated with 94.5%. And even at 1 million tokens, Gemini still lead with 83.1%. And you can see score for others. And this is the last test mentioned over here, global MMLU. What it is, checks if the model can understand and reason in multiple languages beyond English. You can see Gemini achieved 89.8%. So it is showing a strong global language capabilities that you can see here. So overall, Gemini 2.5 Pro is not just a smart chatbot. It's a top tier AI model across science, math, programming, factual reasoning, and even visual tasks, right? So that's what makes it such a strong choice when you are building applications powered by LLMs. So all of you are clear with this, right? This is very important. So now let's move back to Google AI Studio. As we discussed, this is a playground where we can try out different prompts and settings to see how the model responds. And here you can see few options. Chat, to talk with the model, just like a chatbot that you can see. Stream, to get answers in real time as the model is thinking. Video generation, to generate videos using text prompts that you can see. Starter app, helps you quickly build a simple app using Gemini. Let's click over here, chat. And here you can see run settings. From here, we can choose different models for tasks in hand. Let's click over here. You can see Gemini 2.5, Gemini 2.0, Gemini 1.5 and preview that you can see here. Now, very important task. To get the API key in Google AI Studio, you can find it on the right side at the top here. So this key allows you to integrate the model into your applications and interact with it programmatically. So let's click over here, get API key, and before we generate this particular key, let's click over here, API plan billing, and you can see here different model pricing that you can see. Let's click on Gemini 2.0 Flash. Here you can see free of charge and pay as you go per 1 million tokens in USD. Let's first discuss this free of charge. 15 requests per minute, 1 million tokens per month, and 1500 requests per day. You can see price for input and price for output. This plan is free of charge for both input and output with this rate limits, and it does not support grounding with Google search, but data is used to improve the product that you can see. So using data to improve product means that interactions and inputs from users are collected to refine the API's performance and accuracy. This helps enhance the AI's responses and capabilities over time. Please remember, it's essential to review the privacy policies to understand how your data is handled. Now, let's discuss pay as you go per 1 million tokens in USD per 1 million tokens. You can see rate limits, 2000 requests per minute, 4 million tokens per month, and price rate input $0.10 for text, image, and video, 0.70 for audio, and you can see price for output 0.40, and grounding with Google search is provided that you can see $35 per 1000 requests, up to 5000 requests per day. And here you can see data used to improve our product. No, data is not used to improve the product with this plan that you can see. Same you can check for other models as well. But don't you worry. In this video, we are going to use this plan free of charge. I hope all of you are clear with this, right? Now let's move to practical part. For that, we need API key. So for that, let's click over here, get API key. So please remember, to get an API key, first you need to create a Google Cloud account. You can click here, get started for free. Once the account is set up, you can create a Google Cloud project. After that, you can generate the API key. So let's move back, and here let's click create API key. Please remember, currently I'm using AI Studio. www.google.com. Let's click over here, create API key. And here you can see, select a project from your existing Google Cloud projects. So that's why you need to create Google Cloud project first. Then only you can generate the API key. So let's back, and here you can see different projects of mine. Let's click over here and let's click over here, create API key in existing project. And here you can see, use your API keys securely. Don't share them or embed them in code the public can view. Please remember this, right? And you have to copy this particular key. Let's close this. So after that, please create a one notepad file with name .env, right? And create one variable like this, Gemini underscore API underscore key. You can write any, but currently I'm using this variable name, Gemini underscore API underscore key, and equal sign, and paste API key over here that just we have created, right? Done. Let's close this. Now we have generated our API key. Now let's start programming. You can see currently I'm using Jupyter Notebook. First, we will look at how text generation works using Gemini with a single prompt. This means we send one prompt and Gemini returns one response, like asking a question or giving an instruction. Don't you worry, you will understand this shortly. After that, we will move on to the chat models, where you can send multiple messages, kind of ChatGPT, and Gemini responds while remembering the conversation history, just like chatting with a person. So let's get started with a single prompt generation first. Let's create new notebook, and I'm selecting Python 3 kernel, and let's save it with Gemini. You can give any other name as well. So first we need to install this Google-generative AI module. Let's press Shift Enter. You can see for me requirements are already satisfied because I have already installed this particular package, right? You have to install this. Next, we have to import OS, and also we have to import Google.generative AI as GenAI. Let's execute this particular cell. We have successfully imported required libraries. So now next we have to load the .env file where we have stored our API key. So for that, first we have to import this from .env import load underscore .env. Let's execute this cell and let's check load underscore .env. Let's execute this cell once again. You can see means all working fine. Let's retrieve the API key. So for that, we have to write like this, os.environ and Gemini underscore API underscore key. Hope you can remember this. This variable we have created inside .env file, which is pointing to our API key. Let's execute this cell. You can see this is our API key that just we have created. Next, we have to configure our key like this, GenAI, which is pointing to this, .configure API underscore key is equal to this. So this step connects our code to the Gemini service using our unique API key that just we have created. Make sure to keep your API key safe and private, right? Let's execute this cell. Done. We have successfully configured our API key. So next, we have to create an instance of generative model. You can see GenAI, which is pointing here, .generative model, and here we have to provide model name with model underscore name, and we are using this model, Gemini 2.5 Pro Preview 03-25 that you can see here. Let's execute this cell. Done. So this initialize this particular model, Gemini 2.5 Pro, which allowing us to interact with it for tasks like text generation or chat. Now we are ready to send prompts to this particular model. So let's write prompt equal to what is the capital of the India. Let's execute this cell. This is our prompt, and we have to write model dot this model instance that we have created over here. Generate underscore content and prompt. Let's assign it to one variable response. Let's execute this cell. Done. Let's check response. And you can see this is the response from Gemini. You can see content, parts, text, and role model. Finished reason stop, and you can see here. And we are using this particular model version. That also we can check like this model underscore name, the model that we are currently using. Let's check type of response, and you can see this particular object generate content response. Let's check response dot text, and you can see here response format candidates content parts, and you can see this particular response for our prompt generated by model. Finish reason stop, index 0, and you can see here prompt token count, candidates token count, token total token count, and current model version that we are using. This text is being generated for our prompt, this particular prompt, right, which is a part of text. Also we can check model name like this model dot model underscore name, this model. Let's press shift enter. You can see this particular model that we are using. From this response we are interested in this particular text only. So for that we have to write response dot text only, and this is our text that we want from the model. So actually we can be more creative, not just asking question like what is the capital of India. Let's write something like this. This write a poem about a rainy day. Let's press shift enter here and here as well, and you can see model response. So we can also generate creative answer as well. Again we are interested in text only, response dot text, and you can see, right? Also you can format this. So for that we have to import this from ipython.display. We have to import markdown, and in this markdown let's write response dot text. Let's press enter, and you can see the output, right, that we have asked for. Write a poem about a rainy day. It looks nice, right? This way we can perform text generation. Now before we move forward to chat, let's create web app using Gradio. Creating app using Gradio is super simple and very fast. So before we move on, let's create function to interact with Gemini. Here we wrote code line by line, but now let's create function f get underscore response, and input is prompt, and you can copy other parts as well, but currently I'm using this prompt, and it returns response dot text. Let's execute this cell. Done. Let's check it once. Again let's give this particular prompt and let's call this particular function. Oh sorry, here let's execute this cell and this as well. Sorry for that. Now done means our function is working properly. Now let's create web app using Gradio. So Gradio is a Python library that lets you build interactive UIs for machine learning projects. It helps you quickly create web apps where users can input data and get real-time outputs from your model, making it easier to demonstrate and share your work. It's a very simple. So first we have to import Gradio as gr, and here gr dot interface, and just here we have to pass our function that just we have created. Here you can give inputs equal to text and outputs is equal to text as well, and also let's give title text generator. Let's press enter. Done. You can see Gradio objects has been created. Now we have to launch this particular app. Assign one variable as an interface. Let's create this particular variable, and using this iface dot launch, let's execute this cell. Done. You can see here our nice text generation GUI using Gradio. As simple as that. Just in this particular method of Gradio interface method, we have passed our function, this function. As simple as that, right? And here you can see running on local URL. Also, you can provide prompt over here and you will see the output over here. Let's click over here. You can see nice GUI. What is machine learning? Let's press submit, and you can see the output text generated for us. using Gemini, that you can see, as simple as that. So now that we have seen how to generate a single response from a prompt, let's take it a step further. Next, we will explore chat model, where the model keeps track of the conversation history, just like a real conversation with a friend. So let's move on. This means the model remembers what you said earlier and responds in a more natural and continuous way. Let's see how to do that. So first, initial steps are common. First, we have to import OS, and also we have to import Google.generative.ai as GenAI. Also, we have to import from .env, we have to import load_.env, right? This step is required to get our API key that we have stored inside .env file. Next, we have to configure our API key just like before. Let's execute this cell. Done. Please remember also here we have to create instance of generative model. Again, we are using Gemini 2.5 Pro. Let's execute this cell. Now for chatting, we need to create a chat instance. This helps the model keep track of the conversation flow. For that, we have to write model.start_chat, single line, right? Let's give instance name as chat. Let's execute this cell. Done. Let's check type of chat, and you can see here chat session. So this confirm that chat is now a chat session object, which lets us send multiple messages while keeping track of the conversation history. Next, we have to send message like this: chat this particular instance dot send_message, and here I am giving this particular message. What is machine learning? Explain in short. Let's execute this cell. Let's print response.text, and you can see here output from our model chat.history, and you can see here parts text, you can see role user that we have asked as a user, and output from model role model. So each entry includes both user message and model's reply. So since we have already asked what is machine learning, the chat model remembers that context. Let's send next message. Let's copy this, paste it over here, and here I'm just writing give types. Let's press enter. So let's check response first, and you can see here main types of machine learning that you can see. So as we just discussed, since we have already asked what is machine learning over here, the chat model remembers that context. So now when you say give types, it understands that you are referring to the types of machine learning that you can see here, right? Like supervised, unsupervised, and reinforcement learning, right? This is the power of chat-based models. They keep track of the conversation flow, making it feel more natural and human-like, that you can see here, right? Again, let's check chat.history. And here you can see parts, text, role, user message, model's response, again, user's message, and model's response that you can see here. Okay, let's understand this properly. So we can looping through this. So for item in chat.history, let's print item. You can see over here. And again, to check it properly, let's create two lines in between. You can see over here parts text, role user, again text, role model. You can see role user. Also we can print just role as well, item dot role. This, let's execute this cell. You can see user model. We can also grab actual text as well. Let's execute this cell, and we want to grab this particular text. So you can see it is part of this parts. For that, we have to write dot parts index 0. You can see only text, and let's write dot text. You can see this way we can grab only text from this history. I hope all of you are clear with this, right? Let's again display only role. You can see user model, right? And let's remove this, and let's print different items from chat.history that you can see parts text role, right? User model. user, and model. Likewise. Hope all of you are clear with this. So now let's create web app using Gradio for this chat. And this is very important. So now let's move on and let's create web application using Gradio. So we start with usual imports. Let's execute this cell. And here we are configuring the Gemini API. Now we are loading the Gemini model. So these are the same steps that we have been following since long. So now we are going to discuss a very important point, the message structure. So you can see the structure of prompt messages sent to Gemini. You can see it means Gemini wants the chat history to look something like this, a list of dictionaries. So this format tells Gemini exactly who is speaking. You can see role, user, role, model, role, user, role, model. Likewise, and also what they are saying, which is including inside parts, text, and please consider this role, user, role, model. Likewise, list of dictionaries, right? So Gemini wants the chat history to look something like this. Now next, we will write a function with name chat_with_Gemini. You can use any other name as well, which takes two parameters, message and history. You can see here, message and history. So this message represents the current user message and this history represents all previous messages, means the entire conversation so far. So the structure of history is list of list that you can see here, nested list, where each sublist contains what the user said and how the model replied. So this first part, what the user said. Second part, how the model replied. Same here, what the user said and how the model replied. So now the question is, why are we writing the function with these two parameters? Please remember, because that's the format Gradio expects with its chat interface. Don't you worry. Shortly, you will understand everything. So Gradio expects the function that takes message and history as parameters and it returns the response to the message. Now our job is to convert Gradio's format, this particular format, into Gemini's format, because Gradio stores chat history like this, but Gemini expects the chat history like this. So as I said, now our job is to convert this Gradio's format into the Gemini's format like this. In other words, we are transforming this Gradio's format to Gemini format. So we want to build a history structure that Gemini understands like this. Hope all of you are clear with this. Let me repeat one more time. Gradio stores chat history like this, but Gemini wants the chat history to look like this. So now it's our job is to convert Gradio's format into the Gemini's format, which is like this, list of dictionaries. So now let's break down the function code. So this particular line, first we start a new chat session and this is our function. Each takes two parameter, message and history, that we already discussed, right? With name chat_with_Gemini. You can use any other name as well, but it requires these two parameters, message and history. And here we create an empty list with name messages to store the conversation. And here we are printing the history just to inspect it. Now our main for loop. So we loop through each Gradio message pair, this list of lists. And here we are unpacking the list, user message and model response. And here we create entries in Gemini's required format, this format, right? List of dictionaries that you can see here. Very simple. One entry for the user message and another entry for model's reply. So this will create this particular format. From this format, from Gradio's format to Gemini's format, as simple as that. So this builds the full Gemini style history. Now here we append the latest user message to this particular list. Here we are printing messages just to inspect it. Now here we assign the complete conversation means chat history to Gemini's chat history. Means here we are assigning messages, all the messages to chat history of Gemini. And finally, we are sending it to Gemini for a response. And here we are returning plain text as a reply. Hope all of you are clear with this. Just remember, this particular part converts Gradio's chat history to this particular format because Gemini wants the chat history to look like this. As simple as that. Now here we also created one extra function with name response to integrate with Gradio's interface. It is doing nothing. It is just calling this particular function chat underscore with underscore Gemini with two parameters, message and history. So it will call this particular function. Now done. Now we want to turn this particular code into the kind of UI like this that I showed you at the beginning of this particular session. This. Please remember, it's a very simple to create this chat interface. This is just one line of code, right? This is just one line of code that you can see here because Gradio provides a built-in chat interface, this particular method, and this interface expects a function that takes two parameters, message and history. That's why we have created this particular function which takes two parameters, message and history. As simple as that. So if we write a function in this particular format, then for a Gradio, it's just a single line of code to create such user interface that you can see here. Yes, it's just a single line of code for the Gradio. And here we have to pass this particular function. This function is calling this particular function. As simple as that, right? With these two parameters. So we are calling this particular function over here. And here we have provided title to our chatbot, this one. And here we are providing theme, soft. And here we are providing the user different examples like this that you can see here. So now let's execute this code, this and code for our UI that we have created using Gradio. And with this particular method, chat interface of Gradio, let's execute this cell as well. We can chat from here as well, but I prefer this running on local URL. Let's click on this URL and let's ask our first question. What is machine learning? Let's press enter. So you can see the response from Gemini. Let's ask another question. Give types. Please see it carefully. I'm just providing give types without any context, and you can see the types. The question is why I asked this particular question, give types, because I want to demonstrate context. It remembers what we already talked, right, about machine learning, and it is providing give types as per the previous context that you can see here. Three main categories that you can see here. So every time we interact with the chatbot, this particular function will be called chat underscore with underscore Gemini. It builds the entire conversation history and sends this entire history to Gemini model that you can see here. We can see all the history because here we have printed history and messages. You can see first history is empty, then messages. Then you can see history is list of lists. Then message is in Gemini format that you can see list of dictionaries, and you can see this entire conversation. So as I said, when chat underscore with underscore Gemini method is called, it builds the entire conversation history that you can see here, and it sends it to the Gemini model. And here you can see in Gemini format what the user asked and what the model replied. Likewise, hope all of you are clear with this. So please remember, Gemini doesn't have memory of past conversations. It doesn't remember what we said 20 seconds ago unless we include that history ourselves. That's why with every new message that you can see here, we pass the entire history again. That's what gives it context to respond meaningfully. This is the core of building conversational AI, also called as chatbot. Please remember this. Again, I am repeating, Gemini doesn't have memory of past conversations. It doesn't remember what we said 20 seconds ago, unless we include that history ourselves that you can see here. That's why with every new message, we pass the entire history again. That's what gives it context to respond meaningfully, like this. So when I ask something, explain anyone, we pass this entire history again to Gemini. You can see here. We ask explain anyone and it replied with supervised learning that you can see. That's what gives it context to respond meaningfully that you can see here, right? So we are passing entire history again. That's what gives it context to respond meaningfully that you can see here, right? Conversational AI and chatbot. I hope all of you are clear with this, how it is maintaining context. So now let's move on. So now we are going to discuss very important thing that will help us to create LLM powered applications. So we are going to discuss system role and user role in prompts. So now let's start with system role, also called as system prompt. System prompts sets up the model's behavior and environment, defines guidelines for the entire conversation. It defines guidelines for the entire conversation. Please remember this. System role or system prompts defines guidelines for the entire conversation. And here is the example of system prompt or system role. You are a financial advisor with expertise in the personal finance and investment strategies. Provide accurate and practical financial advice that you can see. So here we are setting system role or system prompt. As I said, it defines guidelines for the entire conversation. And here user role, the specific instructions or questions you give to the LLM. So as you can see here, as a system role, we already defines the guidelines for the entire conversation. And here user asks the question as user prompt. What are the best ways to save money for retirement? So it will give the answer as per these guidelines that we have set over here as a system role or as a system prompt. So please remember, system role is equal to a teacher's personality like strict, friendly, expert, etc. And user role is equal to the specific question a student asks. Both roles work together to create a meaningful response. Let me show you one example. Let's jump to Hugging Face Playground. So as you can see, currently we are using Hugging Face Playground and assume that we are going to create LLM powered application for clothing store. And here our system prompt that you can see. You are an AI assistant for a clothing store. Your task is to assist customers with their inquiries about available products, discounts, and promotions. Follow these rules. First, we sell caps but not shoes. If a customer asks for shoes, politely inform them that we do not have shoes but suggest other available items. Next, if a customer asks about a discount, inform them that there is a 40% sale on the selected items. Third, always respond in a friendly and professional manner, ensuring a smooth shopping experience for the customer. That you can see here we are setting system role or system prompt, which defines guidelines for the entire conversation. Now suppose here user asks a question like, do you have shoes? Let's press run. You can see our response as per our guidelines that we have set as a system role or system prompt. Here you can see a response from our LLM. I'm sorry, we don't carry shoes at our store. However, we do have a great selection of caps that you might be interested in. That you can see here. It is responding as per our guideline as our system role. Additionally, we currently have a 40% sale on selected items that you can see that we have set a guideline over here as a system role, which might be perfect for finding something you love. Let me know if you would like more information about our caps or they sell. Let's ask one more question. Do you have black caps? As you can see, the response. Yes, we do have black caps available. You can see. Also here it is informing, don't forget that we have a 40% sell on selected items that you can see as per our system rule. Right? So I hope all of you are clear with how LLM powered application works that you can see here. I will show you how to write code with system role and user role, where we will define system prompt and user prompt through a code. But you can see the output is from our guidelines, which we have provided as a system prompt, right? So this way we can create LLM powered applications by creating system prompt, also called as a system role, and user prompt, which is provided by the user to our apps. Now let's move on. I think this is the right time to discuss very important property of the LLMs, large language models, context window. Yes, we are going to discuss context window. A context window is the maximum number of tokens that AI models like Gemini or ChatGPT can see or remember at one time while generating a response. I'm repeating, a context window is the maximum number of tokens that AI models like Gemini or ChatGPT can see or remember at one time while generating a response. So let's start with what are messages in chatbot. So in chatbot conversations, every line, whether it's you asking a question or the model giving a reply, is called a message that we have discussed earlier, right? Each message has a role. There are three types of role: system, user, and assistant, also called as model. So think of it like a classroom scene. Just for an example, so here you can see role: system, the teacher giving instructions. Example, be polite and helpful. Another role: user, like a student, the student asking a question. Suppose, what is the capital of India? And here next role, assistant or model. So the chatbot giving an answer like the capital of India is New Delhi, right? So there are three types of roles. So as I just said, each message has a role. There are three types of roles: system, user, and assistant, also called as model. So please remember, system role means this is the instruction or behavior guide for the model with setting the tone and purpose for entire conversation. Please remember this, right? So I am repeating, system role means this is the instruction or behavior guide for the model with setting the tone and purpose for entire conversation. Now, user role means this is the input or query from the user. And assistant or model role means the response generated by the model based on the user's query and the system instruction, right? Okay, so now let's move on. Another question is, how does the message flow work? To understand this, please think of a notebook where every single line of this conversation is written down in order. So let's say the conversation looks like this, that you can see here. System message, like you are a helpful assistant, and user message, what is Python? And you can see reply from the model as assistant or model. Python is a programming language. Another user question, who created it? Reply from the model, Guido van Rossum created Python. Now another message from the user, when was it created? So now when the assistant sees this particular latest question, when was it created, it doesn't just read this particular question. It flips through the entire notebook from the beginning to understand the context. So this notebook, which stores all the messages in order, is called the message history, and it becomes the context for the assistant to generate a relevant answer. So now the question is, what happens when a message is passed? So now here we are going to discuss how the chatbot processes a new message using the history. So in the first step, user types something like this particular message when it was created. In the second step, the chatbot collects the full conversation history like this, right? So this particular history is the format of Gemini, but the different models have their own format for chat reply. So as I said, the chatbot collects the full conversation history, which is something looks like this. You can see system, user, model means assistant messages. Again, user, model, user messages. So this entire message list, which contains system, user, and assistant roles, gets bundled together. You can imagine it like a printing all the pages of the notebook and handing it over to the LLM. Now in the next step, the entire message list is sent to model that we have already used, send underscore message. So the entire message list is sent to the model, this entire list, right? So the model reads everything, the system instruction and all back and forth messages before generating its reply. Now in the fourth step, the model generates a response or reply like this. After reading this entire conversation, means after reading this entire notebook, this model generates a response like this. Python was created in 1991. So this new assistant message gets added to this particular notebook and ready to be used if the user asks follow-up question. Hope all of you are clear with this, right? So now the another question is how long this notebook be. So please remember the notebook has limited space. This is called the context window. Every word, punctuation mark and space is turned into tiny units called tokens. A model like Gemini Pro 1.5 might handle up to 1 million tokens, while smaller models like GPT 3.5 handle around 4,000 to 8,000 tokens. So if the notebook gets too long, the oldest messages starting after the system message are cut off to make room for new ones. That means the assistant might forget things you said earlier if your conversation is very long. Now let's revise it once. Every line in the conversation is a message with a role. System, user, or assistant. Messages are stored in order like a notebook to create context. Next, when you send a message, the entire notebook is passed to the model to help it answer smartly. Next, this message passing is limited by a context window, the memory size of the model. Next, if the notebook gets full, older pages get erased. Hope all of you are clear with this, right? What you mean by context window? This is very important. So please remember, this is how smart chatbots keep track of conversations, not by remembering like humans, but by reading structured messages, histories again and again. Hope all of you are clear with this, right? So please remember, Gemini doesn't have memory of past conversations. It doesn't remember what we said 20 seconds ago unless we include that history ourselves. That's why with every new message that you can see here, we pass the entire history again. That's what gives it context to respond meaningfully. This is the core of building conversational AI, also called as chatbot. Please remember this. Again, I am repeating, Gemini doesn't have memory of past conversations. It doesn't remember what we said 20 seconds ago unless we include that history ourselves that you can see here. That's why with every new message, we pass the entire history again. That's what gives it context to respond meaningfully. So now let's move on. Let's enhance our chat bot. So for that, we are going to add a system message to our chat bot. So before updating our code, let's first discuss it using Hugging Face Playground. Then after, we will change our code. So please remember, a system message is a special instruction given to a large language model, LLM. Before a conversation starts, it sets the rules, tone, personality, or behavior of the model. A simple system message is something like this that you can see. You are a helpful and friendly assistant who always explains things simply. You can see in this simple system message, we are setting the tone and persona like you are a helpful and friendly assistant. Also, we are setting the tone and style that you can see, who always explains things simply. So as we just discussed, a system message sets the rules, tone, personality, or behavior of the model that you can see. So let's look at another system message. Let's jump to Hugging Face Playground. And here, just I have added this particular system message. You can see, you are a helpful assistant in a mobile store. You should gently encourage customers to check out phones that are on sale or newly launched. Mid-range phones are 20% off this week. For example, if customer says, I need a new phone with good battery life, you can say, great choice. We have some mid-range phones with excellent battery life and they are on sale this week. You can see this is the system message, and you can observe in the system message we have used role-based prompting. You are a helpful assistant in a mobile store. So this gives the assistant its role and setting. It now acts like a retail assistant trained to help customers. So this is called as role-based prompting. You can see the tone that we have set in this particular system message. You should gently encourage customers. This sets a polite tone, making the assistant sound and customer friendly. You can see in the system prompt or system message, we have provided facts. Mid-range phones are 20% off this week. So this is a fact given to the model. Please remember, even if it is fictional, the assistant will use it during the chat. Please remember this. Here also we have used one-shot prompting. Here's one example that you can see over here. For example, if a customer says, I need a new phone with good battery life, you can say, great choice. We have some mid-range phones with excellent battery life and they are on sale this week, that you can see here. Here we have used one-shot prompting. So this way we can use system message. It sets the rules, tone, facts, personality or behavior of the model. You can see now user asks this particular question. I need a phone with good battery life and currently I'm using P4 LLM of Microsoft. Let's press this particular button, run. You can see output from assistant, also called as model, right? Great choice. We have some fantastic mid-range phones with excellent battery life that you can see, which are coming from this particular system message that just we have set, that you can see over here. This way we can set system message as per our requirement. As you can see in this conversation, we have used three messages: system message, message from the user, and reply from assistant or model. Now let's move to Jupyter Notebook and let's add this system message to our chatbot. As you can see here, I have defined a system message or system prompt. So in Gemini, we have to provide this particular system message like this. Inside this particular method, generative model, and we have to set this particular parameter of this particular method, generative model. And here you can see we are assigning our system message to this particular parameter, system underscore instruction of this particular method, generative model. That's all. And here we are using exactly same code as we discussed earlier. As I said, just I have added this particular system message and assign it this particular system message to system underscore instruction parameter of this generative model, nothing else. Now let's execute this code. Also let's execute this code and let's run our GUI, which we have created using Gradio. Let's click over here. So you can see currently we are going to talk with our mobile store assistant. Let's start. Hi there. And you can see reply from our mobile store assistant, means our model. Hi there. Welcome to our store. How can I help you today? We have got some exciting news arrivals and fantastic deals running this week, especially if you are looking for a great value. Now let's ask another question. I need a phone with good battery life. And you can see here, excellent choice. Battery life is a top priority for many people. We actually have several mid-range phones that really shine in that department. And the best part is all 20% off this week that you can see here. Would you be interested in checking out some of those models? We also have some newly launched phones that boost impressive battery specs. And you can see here, it got this particular knowledge that we have supplied it using system prompt or system message that you can see over here. And here you can see nice communication style as we mentioned in our system prompt or system message that you can see over here. And you can see the advantage of using system prompt. So using this system prompt or system message, we can set tone, personality, etc. And here also we have used one-shot prompting like this. If customer says this, you have to tell this. Same way we can use few-shot or multi-shot prompting here. So because of the system message, now our model knows how to reply. So let's ask such question. For that, fact is not defined inside this particular system prompt. So now let me ask, do you have feature fonts? You can see yes, absolutely, because we have not provided any such facts inside our system message. That's why it replies as per its default behavior, as per its pre-training. So now let's add this particular fact regarding feature font to our system message. And again, we will check reply from our model. And here we are adding this particular message to our system message. If the customer asks about feature fonts, inform that we focus on smart fonts, and also mention the 20% off sale on mid-range fonts. Now let's execute it one more time. This and this as well. You can type message over here, but I prefer this. Now let's ask, do you have feature fonts? Great, because we have provided facts regarding feature font to our system message. So now it replies smartly, that you can see over here. And you can see the replies. We actually focus on smart fonts here, while we don't carry feature fonts. Great. And also regarding 20% off this week on mid-range options, that you can see over here. Great. So this way, system message sets the rules, tone, personality, fact or behavior of our model, that you can see over here. I think this is enough discussion for this particular video regarding chatbot. In the future, we will discuss more regarding this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.